Hello everyone, welcome to the Law of Sines lecture. What I'm going to do is I'm going to cut this lecture in half because I'm only allotted 15 minutes for this screencast-o-matic software. So as soon as we get to the ambiguous case, I'm going to cut it short and pick it up where we left off on the second lecture. So first of all, the Law of Sines is basically a relationship between the sides of a triangle and the angles of a triangle. You can set up a proportion that says little a over the sine of big A is equal to little b over the sine of big B is equal to little c over the sine of big C. And this is a great relationship because if you have, say, like little a and big A and big C here, you could figure out what little c is equal to. Now, the law of sines can also be written with little a, b, and c in the denominator. We're going to go through the first two examples here. Before we do, I'm going to talk a little bit about the proof. It's pretty easy, so I figured I'd introduce it to you. So we're going to look at this triangle here, A, B, C. And here we have a height drawn from the top of the triangle down, which makes a right angle here. And so basically what we're looking at are two separate triangles. And we see these two equations over here. The sine of B is equal to the opposite over the hypotenuse. We're looking at this particular triangle right here. And I think you guys can see that. I'm highlighting that right now. Okay. And the other triangle that we're looking at is this one right here. And the sine of A is equal to the opposite over the hypotenuse. So we have sine of A is equal to h over B. So what we're going to do is we're going to solve for h with both. And so we have two equations that have h equal, which means that we can set both of these equations equal to each other. Now, if we were to divide both sides by the sine of A and the sine of B, we would end up crossing some things off here. We could cross off sine B here and sine A here, and that gives us the law of sines. And that's how the law of sines is derived. Let's go ahead and see some applications with the law of sines. First triangle we're looking at here is an SAA triangle, and we have two angles and a side, and we want to figure out what these two sides are equal to. Now, the angle is pretty darn easy to figure out. You guys know how to do that from your days of geometry. Add up the two angles and take it away from 180, and that gives us a 71. And so from here we're going to figure out little a and b. I'm going to go ahead and start off with little a. I know that little a over the sine of 46 is equal to 56 over the sine of 63. So in order to solve for little a, I'm going to have to multiply both sides by the sine of 46. And sine of 46 crosses with the sine of 46, and that gives us little a equals 56 times the sine of 46 over the sine of 63. Now we could make some pretty good guesstimates as to what this is equal to based on, our knowledge on what the sine of 60 is and the sine of 30 and all that, but we got to use a calculator to figure out the really close exact answer. So we have calculator, 56 times the sine of 46, enter, divided by the sine of 63 is equal to 45.2. So that gives us little a. And now I want to figure out what little b is equal to. And so I'm going to set up another proportion. Little b over the sine of 71 is equal to, I'm going to use this same ratio again, this 56 over the sine of 63. And the reason why I'm using that ratio is because 45.2 is not an exact number. It's very, very close, but it's not exact like 56 is exact. So we got to solve for little b by multiplying both sides by the sine of 71. And that gives us little b is equal to 56 times the sine 71 over the sine 63. So we got 56 times the sine of 71 divided by the sine of 63, which is equal to 59.42. So let's go on to the next problem. This one here, we got an ASA triangle, and we have to figure out all the different sides here. So first of all, let's figure out what the angle is. 50 plus 33.5 taken away from 180 is going to give us a 96.5. Smooth jazz. Sounds like a radio station, doesn't it? So let's go ahead and start finding out these sides here. I'm going to go ahead and try and find out what C is to start. So we have little c over the sine of 33.5, which is equal to 76 over the sine of 96.5. So we're going to go ahead and multiply both sides by the sine of 33.5. That's a point there. Sine of 33.5. And these cross off, and we got little c equals 76 times the sine of 33.5 divided by the sine of 96.5. So 76 times the sine of 33.5 divided by the sine of 96.5 is equal to 42.2. Alright, let's figure out the other side. Adam, can you please sit down? Yeah, focus. Thank you. Okay. Alright, so we're going to solve for little a here. We have little a over sine of 50 is equal to 76 over the sine of 96.5. And if we solve for a, we end up with 76 times sine of 50 over sine of 96.5. And that means that our a value is equal to 58.6. 58.6. Alright, so that brings us to the ambiguous case, which means I am going to stop talking, close shop right now, and load this video onto YouTube, erase it, and pick back up right here where I am leaving off. So I hope you enjoyed this very first pre-calculus screencast. It was made just for you.